Hey guys, welcome to fitting your distribution to your data, and let's see how we can use the StatFit to help us with our models. So this is the icon in our analysis tab where we can find the StatFit. But let's first talk about some background and information about data distributions before we get to work on StatFit. So the typical Promodel data distributions are what you can see in this slide. So the first one being is the normal distribution. In this case, we have a n, which means normal, and then you have 12,3. 12 means the average or the mean, and standard deviation of 3. So you can see here in this chart you have the bell shape. Looks like it's a bell shape. The bell shape, you can see the distribution. It's about the same amount of sigmas to the left, same amount of sigmas to the right. So you can say that 68% of the population falls between the green zone, or 95% of the population falls between green and yellow zone, or 99.7, including the green, the yellow, and the red. So that's what means the normal distribution. You have also the U distribution, which is uniform. 10,1 means with a center of 10 and half a width of 1, which means if you interview someone that says, my data ranges from 9 to 11, so that means that the midpoint will be 10 and the range is 2, so half of 2 is 1. That will create your uniform distribution of 1. So here we have an example of how the uniform distribution looks like. Let's say this is your 9, your 11, and the midpoint falls here, and half a width you have these are some of the formulas to calculate that, but basically this is a way to know uh, set up a uniform distribution, how it looks like. The triangular means that it looks like a triangle. Basically, you have a minimum of 1. The one that appears more frequently is a 2, but you have a maximum of 3. So let's say during your interview, you ask the question of what's been the max and the mean, and then what's the most frequent that occurs. So that gives you a triangular distribution. A triangular distribution looks like this: your mean and max, and the one that occurs the most, mean and max, and the ones that occurs the most. So these are your triangular distributions. And then the exponential distribution is usually applicable for arrivals. So 5 means a mean in between events, a mean of 5. And the exponential distribution looks like this. So the mean will fall here, and sometimes you can have more or you have less, but this occurs through the time. So the exponential distribution looks like this. Okay, so hopefully with this you have an idea of the common distributions that we have used, and there's some others I won't be able to explain, the Weevil distribution and the others that are out there in StatFit, but these are the most frequent. Now, if you don't have data, in the absence of data, all you have to do is to ask the question, right? What is the single most value that can occur in your system? Let's say it's about 10 customers an hour. Yes, or how long it takes to assemble a part, all the say it takes about 20 minutes, right? So this is kind of the basic data out of your information, and obviously you need to do a due diligence on data collection, your time studies, work measurements of every single activity. but this is something that you can do a prelim simulation of your current state. Uh, this is another way that you can do. Let's say the minimum maximum range is from 1 to 3, the amount it takes to inspect the part. So now you can use some of the U distribution, uniform distribution, or you can say my customers arrive between 5 to 10 an hour, or the time to set up the machine is 4 to 6. So what is you can use a U distribution here and say that the midpoint is 5 between 4 to 6, and now you know your width is 2 minutes and half of that is 1. So now you can derive that your distribution for setting up that machine is 5,1. So or if you know already through your interview that the minimum is 12 and the maximum is 15 to repair the machine, but the most likely to occur is 5 minutes. So that means that you can build a triangular distribution that says you have a T where the minimum is 2 and the one that most likely to occur, right, is 5, and then when the maximum will be 15. So, okay, so this is one way to describe your triangular distribution for 2 to 15. But guess these are the ones that you can use the most. So now let's talk about the statistical analysis that we can do in a StatFit. So after obtaining a large amount of data, we must just copy and paste into StatFit. But I want to let you know when you hit StatFit, you're going to get automatically the analysis of what is the mean, median, mode, standard deviation, the variance, the coefficient of variation, and the skewness and kurtosis of that. So let's say that you, after exporting the data into StatFit, this is pretty much the data that you're going to get, right? In the case of these data points, as you can see here, you have immediately the result of what is your median, mean, and max. So you can actually, with this data analysis, you can actually build your preliminary, uh, let's say, a uniform distribution based on this, or you can set up a triangular distribution now that you have the mode. So you can also find out how much variation you have in your process. You have the standard deviation as well, and you have the coefficient of variation. So let's see what is the definition of all of this. So the mean is obviously your average value, right? The median is the one that is in the middle of your observation. You have, let's say, 2, 3, 3, 3, and then 5, 6. So the one that occur in the middle of observation is the median, and you have the mode. The mode is the one that occurs the most. So in the case of the previous example, 2, 3, 3, 3, 4, 5, the one that occurs the most is a 3. So that's the mode. Standard deviation, you already know the formulas. Now all of this is, we assume that you have taken at a statistical course, but I'm not going to go into in-depth of your statistical knowledge, but this is assumed that you already have taken statistics. So about this is just a brush of the general terms of standard deviation, which is your deviation from the mean, your variance, coefficient of variation. This is actually what I'll take a look at the most, is basically, I call it the percentage of deviation by the mean. And if I have a high number, that means there's a lot of variation. The skewness is just based on your symmetry, if the maximum data is farther from the mean, and the kurtosis is how flat it is, or if it's too high in the peak of the distribution. The range is very easy to observe, is your maximum versus your minimum. So, Again, this is just the definition of what you're going to get in a StatFit. Another thing that we need to do for our data is to test for independence, because we want to make sure that each data point of your value stream map is pretty much independent of its own. So we want to make sure the data that we collect, let's say, is not dependent, and we want to go to the difference of that. So for test for independence, we're going to use the scatter plot. When I use the autocorrelation chart, and the run test, I don't usually use it too much, but you can also, this is more of a run chart that tells you also if your data is independent. All right. So now let's take a look at if you do your test for uncorrelated data. This is good because we want to make sure that our data is random in itself, right? So make sure that you have a lot of values and they're scattered all over the place, and that is good for the data that we are collecting, right? We have variation in our process because we want to make sure that our data, this is an example of a correlated data. So let's say that you're collecting data on the temperature data, and as the time goes by of the day, your temperature start to increase. So that means that this is pretty much predictive, right? You can say that as the time, as when the sun arises and then one gets to the lunch time, or it gets after lunch, you get the highest temperature. So we already know that this is temperature, this is data that is correlated. So, but again, if the correlation data, we don't need to use that for our models. This has to be data that is non-correlated. This is another chart that I usually use to check for autocorrelation. So this is good when you have pluses and minus above this line of zero. That is meaning that you have non-correlation. So that's good to know. But guess what happens when you have correlation? When you have correlation, meaning that you have 100% here on your density data, and pretty much it goes like this all the way down. So this an indication that you're dealing with correlated data, and therefore you need to use a different graph for your analysis. So you sometimes may have what is called a binomial distribution, when you have not necessarily you have a normal distribution here, but this is over the time you might have another, so you have like two normal distributions here. But this happens usually in equipment downtime, where you may have two different causes that are creating the downtime. In this case, the first one may be the part jams, and the other one is mechanical failure. So over the course of time, you have two different factors. So sometimes you may just run it as two independent charts. This is related to the part jams, and sometimes independent to the mechanical failures, right? And sometimes you may even have to run just one combination of both. We have another distribution that is related with time, and this is more related to the let's say fast food industry, where you may have let's say you may have customers that arrive very early in the morning. Let's say that your restaurant is want to go open from 10 to 6, and you have more customers appearing at lunchtime, like it shows here. So, and then you show that as the time goes by, let's say at 3 o'clock, you have less customers, and then when it start dinner time, you start to have more customers. Where in this case, you may not need to use a distribution. Promodel has arrival cycles that you can use and enter based on a percentage of time that the people come to your restaurants. So in this case, we don't use a stat fit for that. We use more of a distribution arrival cycles for Promodel, and we want to have another video related on how to set up arrival cycles using Promodel. So the distribution fitting, once you have checked for that, then the next step is to find out if you're dealing with discrete data or continuous data, right? Remember the discrete data that you're handling, it has to be whole numbers. Let's say this is the histogram showing arrivals per 5-minute interval. So in this case, you have the frequency that comes, this arrival count, this is the number of people that arrive, and the frequency is 15. And then for 2, arrival count of 2 is higher, and then it tapers down until you have arrival count of a frequency of 1 for arrival count of 11. So this is kind of based on your discrete distribution, and then your other one is related to the continuous distribution. This is when you have, let's say that your time, the minutes inter-arrival time in minutes. Let's say every 2.5 minutes you have a customer, or every 5.5 minutes. But now you have more fractions of minutes of arrivals. Okay, so, or inspection times. In this case, it's an inspection time. How long it takes to inspect a part? Well, it takes, for this kind of part, sometimes takes 10.5 minutes. For others, takes 12.5. And then we talk about the theoretical distributions, right? So, as you know, all the distribution has a probability count of outcome. Okay, and then you may have binomial, or you may have uniform, or you may have triangular, right? For the uniform is equally likely to fall between two predetermined values. So now you have the optimistic and the pessimistic value. For triangular is best used when there's an absence of data, but the minimum and maximum is known, right? And let me tell you, for experience, usually what I have found is in assembly processes, or manual processes, the triangular distribution is the one that prevails. So whenever you don't have too much data, or the company is giving you limited information, I usually use the triangular distribution for preference. Okay, this is a binomial, it goes like this. Is usually arrivals tend to be the binomial or the exponential. This is the uniform, right? When you have your data that range between 2 points, when you have the triangular, right? You have your mean, your max, and the mode is the one that occurs the most. So let's say that in your interview, you said it takes 3 minutes to operate the machine, and sometimes because you're dealing with large parts, it takes sometimes 5 minutes, but the one that you handle the most is 4 minutes. So that may be a triangular distribution. Okay, sometimes you may deal with something that is more normal, and you have what is called the normal Gaussian, is also known as the bell shape, that where you have data that pretty much is has a bell shape, right? So that you mean that the data varies above and below the mean and is equal distribution. So this is most commonly when you have a large amount of data and they have multiple physical measurements. So This also sometimes you may have exponential distribution that is frequently used to represent data of inter-arrivals. So let's take a look at the normal distribution, how it looks. This is your normal when you have the probability density function of the normal, right? So you have, let's say, the 1 sigma to the left, 1 sigma to the right, and you may have the same amount of data that may fall under a different density distribution. So you may have, let's say, 1 sigma and an expanding 2 sigma, 3 sigma, and you may have the proportions of data falling in those two. This is an example of how the exponential distribution looks like. Like I said, if you have a E5, you're saying that your average or mean distribution of arrivals is, in this case, is a E5. So you're saying that this is how it's going to fall in your distribution for mean arrivals. So so maybe, but this is mostly in arrivals. And now you need to do what is called an analysis of fit test. And analysis of fitness is a test that is called known as the goodness of fit test. So you can use the chi-square method. You can use the Smirnov or Anderson-Darling test. We're going to go and have a video just to explain about this, because this can get into hypothesis testing and it's another chapter. But I just want to mention to you that in case that you formulate how well your data is fitting, it's pretty much is the sample test that says, hey, my sample test is, you can rely on the sample test based on the entire population, and then you can approve it using the null hypothesis, using the p-value. So it all depends on how you want to design your data and the levels of significance, incorporate that into your analysis. Okay, but again, I'm not going to go into too much detail on this. This is supposed to be some of the background that you should have already on statistics, and I'm going to more focus on the mechanical way to use a StatFit. But I'm just going to mention, just in case that you want to know, this is just the short steps to do the chi-square goodness of fit test. But again, I'm not going to expand on this, but this is just for you to follow in case that you're curious on how to conduct your goodness of fit test. But what I'm going to emphasize more is into the 7 key steps for fitting theoretical distributions to data. And this is what I want to emphasize more. So what are the key steps? Now that I have my data, what am I going to do? Well, you're going to follow these 7 key steps. So the first one is to copy and paste import data either from Excel. You can actually copy and paste, highlight in Excel, and then you paste it into StatFit directly. You can also import if you have a CSV data. I'm going to show an example next on how to do it. The step number 2 is to preview the input graph. I also like, before even going to the fitting the data, I like to have an idea how the graph looks like before you hit the out of it. And the other one is check for data independence, like we said in the earlier slides, to make sure that there's no dependency. I have gone to studies where, let's say that you do a drilling operation, and the drilling operation increases as the big parts that you drill, all of a sudden you see that the time increases part by part in a consecutive way, and then you start to see why my data increases as one part processes with the machine, and then you find that the tool wears out when you have big parts processing in the data, so that your drilling time increases as you have more parts going through the system. So that means that the drilling time is correlated with the wear out of the tool. So therefore you should use a different method. So that's one way to know whether you have data independence or is correlated. The other one is this and is knowing whether you are dealing with a discrete or continuous data. Remember, the discrete is a whole number and the continuous is fractions of number. Then you select the out of it. You want to go and select the out of it, which shows you the top ranks or one or more the distributions you can select and test to see which one you're more comfortable and the distributions that you're going to select. You take a look at your goodness of fit test using the Smirnov method or the chi-square and see if that fits what is your design. And last is select and export to the clipboard, and directly you can export the parameter that AutoFit has, which means if it's a uniform, if it's a normal distribution, or if it's triangle, you can export it directly to Promodel into the proper arrival processing or quantity area. So now that you know the 7 steps, let's get to it and let's look at the examples. Okay guys, so let's start now to learn how to use StatFit in Promodel. And what we're going to do is go to the Analysis tab, and then we're going to go to StatFit. I want to open my Excel. This is where I'm going to have my data. And let's say that this is a meal serving time. So these are, I have 10 data points. I usually make, StatFit likes to have at least 10 data points. I usually suggest to be 30 data points. For the sake of this example, I'm just going to use just 10, and I select my data here, select copy, and then I want to paste that into StatFit. Right click and then paste my data into StatFit, or you can also use the menu edit paste. So now StatFit has received my 10 data points for serving the meal times. And what I'm going to do first, like I said in the 7-step method, is first of all, I'm going to check for my chart. I want to have an idea how this data looks like in a simple chart, just to have an idea again to see how this data looks like. So after putting my data in the input chart, in this case that this is not a normal distribution, it doesn't have the bell shape, right? So it's not also a uniform distribution, so you can have just one line here. Independence. The next step is really go to see the descriptive statistics parameters for my information. So here, the statistics is giving the data points. Then from here, I can derive that is the minimum and max. Here, I can derive the coefficient of variation, which is huge, as you can see. And now what I'm going to do is I'm going to go just make the other one is to conduct the independence test. I usually going to do what's the first two is the scatter plot and the autocorrelation. So let's start to do the scatter plot. And you can see that looks like this data is random, which is good. Looks like there's no correlation on that, and I'm happy that it's not. And then I'm going to do another, which is the autocorrelation test. Make sure that I have points above, points below the zero, because remember, if I have 100% points and a density curve that goes from up to down, that means there's correlation, and I need to look for other sources of data or another method of information. So this is telling me that the autocorrelation is random. And now I'm ready to conduct my AutoFit. So AutoFit in Promodel gives you the automatic way to find out whether your data is good what kind of distribution is going to be. So in this case, since my data is whole numbers, this is going to be a what's called discrete distribution, and it tells you what is the lower bound of your distribution is 10. Now, if you're working with processing data, make sure that you don't have a 0, because if you have a 0, that means that your data is wrong. So in other words, you cannot process anything, or let's say a drill process where it takes nothing to drill it. So you may have an error in your data. So before you even paste the data, you make sure that you have a validated data that you're transferring to out of it, right? So if I have a lower bound of 10, that means it's good. If I have a lower bound of 0, that means I have a problem in my data. So you have to do data cleaning, data scrubbing. So you have to do the data cleaning and data scrubbing before you transfer the data into StatFit. So now I have now put my data into discrete distribution, and now out of it is trying to find what is the best distribution that fits my data. So in this case, out of it has auto ranking and has come up with three different distributions. Out of those three is doing the test to see if they accept or reject the distribution, and it looks like there's two that are accepted and one that is rejected, right, based on the goodness of fit data. And in this case, the one that ranks the most is the geometric distribution. So I'm going to put my geometric distribution here. So look at this. This is the geometric distribution that is going to show me how it looks like. And then if I do an export to find what is the parameter for Promodel, is the geometrical distribution, geo, and then this is the number that we need to use for a parameter in Promodel. So we just take it to the clipboard and then paste it into the appropriate processing parameter. In this case, is a meal serving time. So your parameter is going to be weight, geometrical, and then open parentheses 0.027. So this is going to be, in other examples that we have done in the past, is if it's a normal distribution, is weight n open parentheses, and then you put the average, comma, standard deviation. But in this case, it's a geometrical distribution. Okay, so this is how you do this. Is an example of serving time. So now let's do another example doing a gas station car arrival. Okay, now I have 30 data points, which is good. That's something that in any analysis I expect to have at least 30 data points for my analysis. So in this case, this is a problem where you want to measure how often the cars arrive to the gas station. So in this case, the first car that arrives is 12 minutes, 12.3, and then the next one is 5.7, you know, 16.6. So that's good to know. And then what I do is just copy the data, and I'm going to go to my StatFit. By the way, you can save this. Okay, I want to create a new one. You can save it for your analysis and paste it. All right, so now I have my 30 data points here. Then what I'm going to do is I'm going to follow my 7 steps. The first step is to get the input graph, and look at this. Look at this. It's showing more of what is look a uniform distribution, right? When you have a minimum and max here, right? And looks like this is more of a uniform distribution. Now let's test for independence. I'm going to use my scatter plot. yes, that looks like there's a random variance here, and I'm gonna test also for the autocorrelation to see, yes, I have points that are above 0 and points that are mean. I don't see the density function of 100% of that. That means that this is good to go. And then next I do my out of it to find my parameters on my, supposedly is a uniform distribution. That's what I'm betting. But now it's asking me, is this a continuous or discrete distribution? Since there are fractions of time, I'm going to choose a continuous distribution. So, and out of it is already selecting the lower bound, right, which is 5 minutes in this case. If I look at my data, yes. So this is true, this is good because the lower bound is in the 5-minute range. So now I click, this is the assign bound, and then I click OK and calculates the goodness of fit test, which is the next point, is calculating the goodness of fit test. And StatFit comes up with several distributions in this case. And look at this, I have all of this, and the ones that are rejected based on the goodness of fit test is the, so these I supposed not to use those, not to use these Pearson and inverse Gaussian and all of inverse Weibull. These are not good to use, but the ones that are good to use is the power function distribution. And guess what? The uniform distribution, right? And look at this. This is a 97 rank and this is 100. So if I choose the, and you have the Johnson and the beta and the, looks, in my experience, I usually tend to use the, if I have, let's say close to 78, let's say you have a distribution that is 78, and let's say this is the only one that shows up, or you have one that is 61 or a 50. I really don't like to use something that is 50, right? Then if you got something very low in rank, right, based on your goodness of fit test, then I create a greater sample or go back and collect more data. But I like to see these numbers go above the, or near the 80% and above, right? That's just some of my own practice. So, but in this case, I'm happy to see that there's 100, there's a 97 in the rank for goodness of fit test. But let's say I'm going to choose the power distribution. So you click on the power distribution. And yes, what we said is pretty much the distribution. Then I select the export fit in this icon. Just click export fit. And then it's going to give you the parameter that I can copy and paste to Promodel. So once you kick output to clipboard, then you can choose copy and paste, and then you can do wait. Oh, sorry, this is an arrival, so it means that you want to copy and paste this parameter into the arrival area. Okay, now the other thing I also like is I have also a uniform distribution. So let's say you are much better off to use the U distribution because you're more acquainted with the U distribution, and sometimes you can even use it because now you can explain how this distribution works, right? And as you can see, half of the width is 7, so that means that the the average is 12, and then this can be used at the maximum is going to be 19, right? So let's now do a copy on the clipboard. So let's say that you like this distribution more, and it's very close to, because it was about 97, right? So now you can go to Promodel and then put that into your arrivals, right? And right, and then get your arrival frequency, and then you can select another one for your quantity or your number of occurrence, do another distribution here, right? Okay, guys, I hope that you now with these two examples learn how to set up and find your distribution for appropriate data, and I'll see you in the next video. Thank you for watching.